In this video, we are going to talk about how to find the midpoint of a line segment, as well as we are going to talk about the perpendicular bisector, and the two are related. This first slide, we show some instructions as to how to find or definitions on these specific topics, and the page is split in half. So this left side here, we're going to talk about how to find the midpoint of a line segment. The midpoint of a line segment is the point on the line that is halfway between the endpoints. So if you can imagine that we have a line segment with two endpoints, the midpoint is half the distance between each of the two ends. And we find the coordinates of those midpoints, the x mid and the y mid, or the x and y coordinates of the midpoint, by using these formulas here, where the x1, x2, y1, and y2 are the corresponding x and y coordinates of the two endpoints, one endpoint and a second endpoint. Some examples of how to do this will be shown later, and some practice as well. The perpendicular bisector is a line that has these two requirements. The first requirement is that the perpendicular bisector is perpendicular to the given line segment. The way we find that is we have a negative reciprocal slope to the slope of the given line segment. So if we have a given line segment, we find the slope of it. We find the negative reciprocal of that line segment to find the slope of our perpendicular bisector. That is what makes it perpendicular. The bisector part is the second bullet point. It bisect is to mean that it intersects our line segment at its midpoint. So we need to find the midpoint of our line segment using the midpoint equations on the left side of this slide. And that's a data point that lies on our perpendicular bisector, because our perpendicular bisector is a line that goes through the midpoint of our given line. So the next few slides are going to show us how to do questions involving these two particular topics. So question 1 says, determine the midpoint of the line segment CD, with C and D at these particular locations. So let's first start by writing out the formulas for the midpoint coordinates. So the x midpoint can be found by adding x1 plus x2 over 2. Similarly, the y midpoint formula is y1 plus y2 over 2. So let's sub in these data points. And remember, if these data points happen to be negative, we would sub them in with brackets around those numbers. So for example, if we called our C data point our first data point and D our second data point, then if D was negative here, we would sub in plus a negative number for x2 or y2. Anyway, so let's continue with this problem. So we have x1 and x2, so that would be 2 plus 8 over 2, which is equal to 10 over 2, which is equal to 5. For the y coordinates, we have 2 plus 6, 2 plus 6, and that's over 2, which is 8 over 2, which is 4. Therefore, the coordinates of the midpoint of CD would be located at 5, 4. Question 2 says M, located at negative 3, 4, is the midpoint of the line segment AB with A located at 0, 3. Determine the coordinates of B. So this can be found by using exactly what we just did over here, except plugging in the numbers in the appropriate locations for our formulas. So let's first say that let's find B, where B would be having coordinates x, y. And x, y is what we want to find, because that's the coordinates of B. So let's sub in everything we know into our formulas. And let's maybe first write out our formula. So x mid is equal to x1 plus x2 over 2. And similarly, y mid is y1 plus y2 over 2. So the x-coordinate midpoint is -3, so we can replace that with -3. And that'll be equal to x1, which is 0, plus x2, which is our x-coordinate for b, so that's just x, over 2. That's the formula. The y midpoint is 4, so we have 4 equals 3 plus our y-coordinate for b, so y, and that's over 2. So let's rearrange and solve for x and y. So on this side, we have -3 is equal to 0 plus x is just x over 2. Then we want to multiply both sides by 2, so we isolate for x, and therefore x is equal to -6. Over here, it's like we have brackets around this numerator, and we multiply both sides by 2, and we'd end up with 8 is equal to 3 plus y. And if we subtract 3 on both sides, we find that y is equal to 5. So therefore, the coordinates for b is located at -6, 5. We have 2 more questions here. Don't forget to pause the video, try the questions on your own, and then unpause the video and see how you do. So question 3 says, a quadrilateral WXYZ has these vertices. Verify that the diagonals bisect each other. So in order for us to verify that the diagonals bisect each other, we need to first find the midpoints of each diagonal. And if they happen to be the same, well then we know that each line passes through the other line right at its midpoint, therefore bisecting each other. So we could graph these coordinates to find out which vertices are located where, and then find out which line segments would be our diagonals, or we can just inspect and see what we think. So we see that W is located at -3, 2, which is in the second quadrant. X is located in the first quadrant. Y is located in the fourth quadrant, and Z is located in the third quadrant. Therefore, line segment WY would be one diagonal, and the other diagonal would be XZ. So those are our diagonals. We want to find the midpoints of these diagonals. So let's first start by writing out the formulas for finding the midpoint. Alright, so now for WY, we want to find the midpoint of that. So X mid would be equal to the two X coordinates of Y and W. So X coordinate here is -3 plus the X coordinate here is 5 all over 2. So that would be 2 over 2, which ends up being 1. The Y mid is located at the addition of the Y coordinates for W, which is 2 plus -3 for Y, and that's over 2. So we have 2 plus -3 is -1/2. So that's the midpoint coordinates for WY. How about for XZ? So the X midpoint, we'd still want to use this same generic midpoint formula, but now we're dealing with the data points X and Z. So we have 6 plus -4, so 6 plus -4 over 2. And the Y midpoint would be the average of the Y coordinates of our two data points, so 4 and -5, so 4 plus -5 over 2. And we have 6 plus -4, that's the same as 6 minus 4, which is 2. 2 over 2 is 1. And over here, 4 plus -5 is the same as 4 minus 5, which is -1/2. Notice the X coordinates and the Y coordinates of our two diagonals are at the same location, meaning that these lines pass through each other right at their midpoint, therefore bisecting each other. So we can say, therefore, the diagonals bisect each other. And lastly, we have question 4. It says, determine the equation of a line that is the perpendicular bisector of a line segment between C and D. So in order to find the perpendicular bisector of a line, then we must first find the slope and midpoint of our original line. So let's first find the slope of this line. We know that the slope of line segment CD would be equal to y2 minus y1 over x2 minus x1, which is equal to negative 3 minus 3 over 3 minus negative 9, which is equal to negative 6 over 12, which reduces to negative a half. And that's the slope of CD. But the slope of our perpendicular bisector has a negative reciprocal slope. So therefore, the slope of our perpendicular bisector, which is perpendicular to CD, would be equal to the reciprocal of this. So 1 over 2 would be 2 over 1, and 2 over 1 is the same as just saying 2. And because this is negative, we have to multiply that by a negative to get the negative reciprocal, which means this number is positive. So the slope of our line that we're looking to find happens to be 2, because this is perpendicular to our line segment. Now we need to find the midpoint of our line segment. So let's find the x midpoint first, which again we know the formula to. So the midpoint of CD, the x-coordinate anyway, would be located at 3 plus negative 9 over 2, which is 3 minus 9 is negative 6 over 2, which is equal to negative 3. The y midpoint is located at y1 plus y2 over 2. So for C and D, we would have negative 3 plus 3 over 2, which is 0. Because negative 3 plus 3 is 0. 0 over 2 is still 0. So the coordinates of the midpoint, maybe I'll write it here. The midpoint, we'll use maybe MID, xy for the midpoint of our line segment, is located at negative 3 comma 0. So we know that our equation of our line, that is the perpendicular bisector, will bisect if it goes through this midpoint and will be perpendicular if it has this slope. So we know the general equation of a line is y equals mx plus b, where we know our slope is 2, and the x and y coordinates are any two corresponding coordinates for any point that lies on our line. And if it does, it'll satisfy this equation. And we know this midpoint lies on our line, so we can sub in those coordinates for x and y, and the only thing we don't know is b. And if we rearrange this and isolate for b, we'll find out what b would be equal to for our line. So we would have 0 equals negative 6 plus b, and if we add 6 to both sides, we find that 6 is equal to b. Therefore, the equation of the line that we are looking to find is equal to y equals m, which is 2, x plus b, which is 6. And that's our answer for question 4. And that's it for this video.